back. Today we're going to talk about pairs of angles that are formed by parallel lines and a transversal, also known as angle relationships. First of all, what we need to understand is we are talking about the same situation that we've had before with two lines that are cut by a transversal. Conveniently, they have labeled the transversal T. What they haven't told you, or what I haven't told you, is that these two lines are parallel, and that's one of the contingencies of this conditional statement. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So, parallel lines, P and Q, cut by a transversal T, corresponding angles are congruent. The beauty of corresponding angles is that everything corresponds to something. So, for example, the measure of angle 1 is equal to the measure of angle 3. Where do I get this? It's all based on the window principle. And if I'm looking at these windows, I notice that, I'll label it in blue, 1 and 3 are in that upper left-hand part. So that means that measure of angle 1 is equal to measure of angle 3, which means angle 1, not L. Angle 1 is congruent to angle 3. I'm going to go in green this time. 2 and 4, that upper right-hand part. So angle 2 is congruent to angle 4. Let's use a little red. 5 and 7, so angle 5 is congruent to angle 7. And I guess I'll go in, I don't know, it's light blue color. 6 and 8. Angle 6 is congruent to angle 8. Corresponding angles, if they're parallel lines cut by transversal, are congruent. So let's look at what this means. Congruent means the measures are equal. And so if I'm looking at the measure of angle ABC, it's marked with X degrees. Well, notice what happens here. If I'm going to outline these windows, all right, I notice that 80 and X are in that upper middle section there. And so X degrees is equal to 80 degrees. Therefore, the measure of angle ABC is equal to 80 degrees. That's kind of how this works. It's a matching game because the lines are parallel. We know they're parallel because they have these little arrowheads on them. DEF. So I'm looking for this bottom measure here. X plus 30 degrees. Well, I don't know what X is, and unfortunately in this one I've got something else with an X in it, but guess what? We can use algebra to solve. If I outline my windows like normal, I'm going to notice that I have parallel lines, and the upper right-hand part, those are congruent. The measures are equal. So 2x minus 45 equals x plus 30. Well, that's good. I only have one variable. It just happens to be on both sides. So I'm going to subtract x from both sides. Going with the very masculine pink here. X minus 45 equals 30. And I'll just add 45 to both sides. Now, if this was some kind of like proof, I'd say, we use the addition postulate or addition property of equality, but I'm not doing that. Equals 75. So x equals 75. So what is DEF? DEF is x plus 30. Well, I'm going to take this 75 and I'm going to put it in for x. 75 plus 30 equals 105. That's my actual answer. See if you can do this next one on your own. Pretty straightforward. Notice I've got parallel lines cut by a transversal. There are 3 other relationships and angles that we need to respect. I've given you some colors to outline it for you. You only have 2 choices. Two choices for angle measures. I put 3 exclamation points. You only have 2 choices for angle measures in parallel lines cut by transversals. You can kind of see it here. It's either the little one, which are the red ones, or the big one, the blue ones. All of them are the same. And look at why this is. These parallel lines here are cut by this transversal. So that means that if I've got 1, it's a linear pair with 2. Well, 2 is vertical with 5, so 2 and 5 must be congruent. Well, 1 and 6 are also congruent, and because of that corresponding angles theorem, 1 and 3 are the same. So angle 1 is congruent to angle 3. Well, then that starts the cycle over again. 3 and 8 are vertical, 4 and 8 are a linear pair, 4 and 7 are vertical. 2 choices. That's it. You only have 2 choices. It's the big one or the small one. And so when I look at alternate interior angles would be like 2 is congruent to angle 7, or angle 6 is congruent to angle 3. Parallel lines cut by a transversal. The alternate interior angles theorem says in 2 lines cut by transversal, alternate interior angles are congruent. That's all there is. 2 choices. So it's either the red ones or the blue ones. Alternate exterior angles theorem. Angle 1 is congruent to, well, it's the red one, it's the little one, angle 8. Also, angle 5, which is an alternate exterior angle, it's alternate because it's on opposite sides of the transversal, it's exterior of the 2 parallel lines, is congruent to angle 4. Same side interior angles theorem. This is the only key. Same side interior angles theorem. Same side interior angles are supplementary. How does this work? Well, look, 1 and 2 are a linear pair. They form a line, so they are supplementary. Well, if 1 is congruent to 3, we could use the transitive property to say if 1 and 3 are congruent and 1 and 2 are a linear pair, then 2 and 3 must be a linear pair. So, for example, angle 2 plus angle 3 equals 180. I really technically need to have the measure in there. The measure of angle 2 plus the measure of angle 3, same side interior angles, are supplementary. Also, the measure of angle 6 plus the measure of angle 7 is 180. So these are same side interior. These are same side interior. 180 degrees together. 180. Okay? 2 choices. It's either the little one or the big one. Let's look at how this pans out down here. Now this diagram doesn't really look like it, but those lines are parallel. And so let's just mark it. Watch. I'm going to mark this one with 1 arc mark. And then I'm going to go around and mark each other one with the same arc mark. So this one's a corresponding angle. Oh yeah, this one's a vertical angle. This one's a vertical angle. Remember, 2 choices, 8 angles. So there's 4 of each. And so I'm going to mark these other ones with this pinky color. So these are 2. These are 2 marks. These are 2 marks. They're the big ones. Big ones, big ones. So you see how this pans out. Vertical angles are congruent. Vertical angles are congruent. Corresponding angles tie both windows together. And so if I look at this, if I'm looking at DEF, notice what happens. It's a green one, right? It's a green angle. Well, if the pink one is 125, and I know that these are a linear pair, then this one must be 55. So I could fill them all in. Well, this is 125. This is 55. Oh yeah, pink ones are 125, so this one's 125. Notice corresponding with the 125. This is 55. Oh yeah, corresponding. And this one's 55. Vertical, also alternate exterior. And this one's 125. So what is the measure of angle DEF? It's 55 degrees. Because it's a linear pair with 125. It's an alternate exterior angle with the other one that's 125. It's a vertical with one that's 55. Okay, there's a lot of different reasons why it is what it is. Let's look at TUS. TUS, these are all out of order. This should be UTS. So I want this angle here. Well, notice, those are same side interior angles, so same side interior angles are 180, right? So 13x plus 23x equals 180. So that means 36x equals 180. Don't worry, I got us. So let's see. 180 divided by 36 is 5. Well, what does that make this angle? It's 23 times 5 equals 115. That's all there is to it, guys. You just figure out what the relationship is, and then it's one of the two angle measures. So if I wanted to, I could fill the rest of these in. This would be 115. This would be 115. This would be 115. Okay, it kind of works like that. So you have two different angle measures. That's all there is to these angle relationships. Okay, you have two different measures that could possibly be, and all of them are related to one another by linear pair, corresponding vertical angles, stuff like that. All right, guys, thanks for watching, and we'll see you next time.